In this video, we're going to look at another example of moments and centroids. The question here is to find the centroid of the region bounded by the piecewise defined function f of x is equal to 2x minus x squared. This is a downwards pointing parabola when x is between 0 and 2, and f of x is equal to x minus 2 when x is between 2 and 4, and of course x minus 2 is just a linear function. So also bounded by the x-axis and x equals 4, the linear density is given as rho is equal to 2. All right, let's start by finding the x-intercepts of the parabola. This will make it easier to graph the function. So we have y is equal to 2x minus x squared. To find the x-intercept, we'll make y equals 0. So y is equal to 2x minus x squared. Factor the x out, we get x times 2 minus x. Make this equal to 0. X equals 0, making this factor 0, and making this factor 2 minus x equals 0. We get x equals 2. So the x-intercepts are x equals 0 and x equals 2. For this downwards pointing parabola. It's downwards pointing because there's a negative 1 in front of x squared. The coefficient of x squared is negative. That's why it's downwards pointing. All right, so the first step is to sketch a diagram. So we have the parabola here. This is the parabolic section of it. There it is. And we have the line right here. This is y equals x minus 2. The density is 2. So the function f of x is a piecewise function. This is equal to 2x minus x squared. When x is between 2 and 0, and x minus 2, when x is between 4 and 2. So this is a little bit different than the kind of questions we've been doing so far. So our strategy will be the total mass is the mass of the parabolic part plus the mass of the triangle. The moment with respect to the x-axis, the total moment with respect to the x-axis is the moment with respect to the x-axis of the parabola plus the moment with respect to the x-axis of the triangle. We're using additivity of moments. Moments are additive. And the moment with respect to the y-axis, the total moment with respect to the y-axis is the moment with respect to the y-axis of the parabola plus the moment with respect to the y-axis of the triangle. And because this is a piecewise defined function, we have to use additivity of moments to find the centroid of this region. So step 2 is to apply the centroid formulas. Mass is equal to rho, density, times integral from a to b, f of x dx. This is equal to density, which is 2, integrate from 0 to 2, the parabola 2x minus x squared dx, plus 2 times integral from 2 to 4, x minus 2 dx. This part is the mass of the parabolic section, and this part is mass of the triangular section. So now let's integrate. Mass is equal to 2 times. Integral of 2x is just going to be 2x squared divided by 2, reversing the power rules, so the 2's cancel out, we get x squared. Integral of x squared will be x cubed over 3, add 1 to the exponent, divide by the same, evaluate it from 0 to 2. Plus 2 times, integral of x is going to be x squared, divide by 2, reversing the power rule, and integral of 2 is just 2x, reversing the power rule again. Evaluate it from 2 to 4. Now let's apply the fundamental theorem of calculus and find the mass. Mass is equal to 2 times. Put the upper limit in, we get 2 squared is 4, minus 2 cubed, that's 8 over 3. Plug 0 in, we get minus 0, plus 2 times. Put the upper limit in, we get 16 over 2, that's 8. Minus 2 times 4 is 8. Minus, put the lower limit in, 2 squared is 4 over 2, that's 2, minus 4. Now let's simplify this. We get mass is equal to 2 times 4, that's 8, minus 16 over 3. 8 minus 8 cancels out, that's 0. 2 minus 4 is minus 2, times minus is plus 2 times 2 is 4. 8 and 4, 8 plus 4 I should say is 12, minus 16 over 3. And adding these fractions, we get 36. Taking common denominator, 36 minus 16, divide by 3. This is equal to 20 divided by 3. All right. So common denominator is 3. 1 goes into 3 3 times. 3 times 12 gives us 36. And 3 goes into 3 1 times. 1 times 16 is 16. 36 minus 16 gives us 20. All right, so the moment with respect to the y-axis is equal to rho times integral from a to b. The distance to the y-axis is just x times the rectangular, the area of the rectangular element, which is f of x dx. This is equal to the moment of the parabola plus the moment of the line. I should say the moment with respect to the y-axis of the parabolic section plus the moment with respect to the y-axis of the line. So we get 2 as density, integral from 0 to 2, x, which is the distance to the y-axis, times the parabola 2x minus x squared, integrate with respect to x, plus 2 times integral from 2 to 4, x times the line, which is x minus 2 dx. Now we just have to evaluate this integral. All right, so the moment with respect to the y-axis is equal to 2 times integral from 0 to 2, x times 2x minus x squared dx, plus 2 times integral from 2 to 4, x times x minus 2 dx. Let's simplify the integrand before we do the integration. The moment with respect to the y-axis is 2 times integral from 0 to 2, and multiply this x through, so we get 2x cubed minus x cubed. Sorry, this is 2x squared. Let me correct this before the error propagates. So we get 2x squared minus x cubed dx, plus 2 times integral from 2 to 4, x times x is x squared minus 2x. Put this all in brackets, integrate with respect to x. Now let's reverse the power rule and integrate these two integrals. Moment with respect to the y-axis is 2 times integral of 2x squared is 2x cubed divided by 3 minus integrate x cubed, and we get x to the 4th divided by 4. Evaluate from 0 to 2. Applying fundamental theorem of calculus. Plus 2 times integrate x squared, we get x cubed over 3, reverse the power rule. Integral of 2x is simply 2x squared divided by 2, reversing the power rule again, and we just get x squared because the 2's cancel out. Evaluate from 2 to 4. Now let's apply FDC. My, moment with respect to the y-axis, is 2 times. Put the upper limit in, we get 2 cubed is 8 times 2, that's 16 divided by 3, minus 2 to the 4th is 16 over 4 is 4. Put the lower limit in, we get 0 minus 0. Plus 2 times, put the upper limit in, we get 4 cubed, that's 64, divided by 3, minus 4 squared is 16. Now put the lower limit in, we get 8 over 3, minus 4. Close off the brackets. So the moment with respect to the y-axis is, we get 2 times 16 over 3, let's multiply all of this out, we get 32 over 3. 2 times negative 4 is minus 8, plus 2 times 64 over 3 is 128 over 3. 2 times minus 16 is minus 32, minus 16 over 3. And we get minus 4, which is plus 4 times 2, plus 8. Very easy to make mistakes here, so you really have to be careful when you're dealing with lots of minus sign and lots of fractions when we're adding all these fractions. 8 and minus 8 cancel out. So what do we get? We get my, moment with respect to the y-axis, is equal to, we have 32 over 3 plus 128 over 3 minus 16 over 3. If we add all of that up, we get 144 divided by 3 minus 32. So taking common denominator, that's 3. 3 goes into 3 one time, we get 144. And 1 goes into 3 times 32, and we get 96. 144 minus 96, what does that give us? That gives us 48. 48 divided by 3, nice even number, this is equal to 16. That's the moment with respect to the y-axis. Now the key concept here was we had to add up the moments. So we added up the moment of the parabola, moment with respect to the y-axis of the parabola, plus moment with respect to the y-axis of the line. We're using additivity of moments. We'll do the same thing to find the moment with respect to the x-axis. So the moment with respect to the x-axis is equal to 1/2 using the formula, integral from a to b, density times f of x, all squared, integrate with respect to x. Moment with respect to x-axis is equal to 1/2 integral from 0 to 2. These are x limits of integration. Rho is 2 times the parabola squared, 2x minus x squared, all squared, dx. All of this is a moment with respect to the x-axis of the parabola. Now we have to add it to the moment with respect to the x-axis of the line. Additivity of moments. 1/2 integral, now integrate from 2 to 4 because the line goes from 2 to 4. The parabola goes from 0 to 2. So there's no x here. Density, which is 2 times x minus 2, all squared, dx. The 2 cancels with the 2 here. The 2 cancels with 2 here as well. We get moment with respect to the x-axis is equal to integral from 0 to 2. Let's fold all of this out. Makes it easier to integrate. 2x squared gives us 4x squared. Multiply these two terms and multiply by 2. So we get minus 4x cubed. And square this term. Minus x squared squared is plus x to the 4th. Integrate with respect to x plus. Folding this integrand, the second integrand, x squared, we get x squared, and we get minus 4x plus 4 dx. All right, let's reverse the power rule and solve these integrals. Moment with respect to the x-axis is equal to, integrating 4x squared, we get 4x cubed, divide by 3, minus 4x to the 4th, divide by 4, integrating this piece, reversing the power rule, plus x to the 5 over 5. Power rule all the way. Evaluate it from 0 to 2. Plus, integrate x squared, we get x cubed over 3, minus 4x squared, divide by 2, reversing the power rule, plus integral 4 is 4x. Evaluate from 2 to 4, apply fundamental theorem of calculus. So we have to be pretty careful, a lot of fractions here. So 2 cubed is 8 times 4, we get 32 over 3. Minus, these 4's cancel out, 2 to the 4th is 16. Plus 2 to the 5, that's 32. Divide by 5. Subtract 0, because 0, plug 0 in, that's all 0. Plus, now put 4 in, 4 cubed is 64 over 3. Minus, 4 squared is 16 times 2 is 32. Plus 4 times 2 is 8. 4 times 4, that's 16. Minus, now put the lower limit in, 2 cubed, that's 8. Divide by 3. 2 squared is 4 times 2 minus 8. And 4 times 2, that's plus 8. Close off the brackets and close off the square bracket and simplify. So the moment with respect to the x-axis is equal to 32 over 3 minus 16 plus 32 over 5 plus 64 over 3. And we have 16 minus 32, that's minus 16. And 8 and minus 8 cancel out. Minus times 8 thirds, minus 1 times 8 thirds, we get minus 8 thirds. If we do this very carefully, add up all these fractions, it comes out to 56. Divide by 15. If we decimalize this, we get approximately 3.73. This is the total moment with respect to the x-axis. And I'll repeat again, we're applying additivity of moments. The total moment with respect to the x-axis is the moment with respect to the x-axis of the parabola plus the moment with respect to the x-axis of the line. Additivity of moments. All right. So we found the total mass of this system is 20 over 3, the mass of this region. The total moment with respect to the x-axis of this region is 56. Divide by 15. The total moment with respect to the y-axis is equal to 16. X bar is equal to the moment with respect to the y-axis divided by mass. That's going to be 16 divided by 20 over 3. So we get 16 times 3 over 20. Flip the denominator. We get 48 over 20. And this gives us 2.4. This is the x-coordinate of the center of mass of the system. Y bar is equal to moment with respect to the x-axis divided by the mass. The moment with respect to the x-axis is 56 divided by 15. The mass is 20 divided by 3. Flip the denominator, we get 56 divided by 15 times 3 over 20. 3 cancels with 15, we get 5. We get 56 over 100. If we decimalize this, we get 0.56. So the centroid x bar, the x-coordinate of center of mass is 2.4. Y bar is equal to 0.56. Let's go back to the diagram and ask ourselves, does that make sense? So let's go back to the diagram on page 1, or page 2, I should say. So we found the x-coordinate of center of mass to be 2.4. That's roughly here, 2.4. The y-coordinate is 0.56. So that's about here. And that makes sense. If you look at that diagram, we expect the center of mass to be in that part. All right, thank you. I'd like to make a slight correction to this video. So we found the center of mass to be 2.4, and 0.56. This is x bar and y bar. So if we plot this, 2.4, this is correct, that's roughly about here, but 0.56 is not where I drew it. 0.56 is actually above this line. So this is 2.4. 2.4 minus 2 would be 0.4 would be here. 0.56 is actually here. It's outside the region. So it's actually very interesting that the centroid of this region is actually outside the triangle and the parabola. And this has to do with the fact that just with the geometry of this system. All right, thank you.